Hi everyone. In the previous class, we have seen some of the concepts like RAID technology. So RAID means a redundant array of independent disks. So mainly this technology is meant for the purpose of to improve the read performance and also to improve the reliability of the disk. Right? Yes. So we have seen various kind of levels also. Not only this, we have seen disk space manager and buffer manager also we have seen, right? So disk space manager, we have seen some of the algorithms like first fit algorithm, best fit algorithm, how they will work. And coming to buffer manager, we have seen first in first out method, least recently used, etc. Right? Yes. Right, basically disk space manager is meant for to manage where to store what kind of files and when to remove the files from the hard disk is going to be defined by the disk space manager. Coming to buffer manager is a memory which is a part of the main memory. What are the frequently accessed items that I need to place in the buffer? That will be defined by the buffer manager. Okay, fine. Now in today's class we'll see one of the important concept which is related to gate, that is file organization. Means guys, so basically the file means it's a collection of a data. It's a collection of a data. That data can be in the form of a bits, it can be in the form of a bytes, or it can be in any text format, it can be any audio format, or it can be video format, right? For example, if you take any kind of operating system, right? In operating system, your file can be in the form of .doc or .xlsx or .jpg or .jpeg, whatever the may be, whatever the file it may be, it is a collection of some kind of a data, right? Coming to database, here the file represents a collection of data only, but that data will be in the form of a tables, right? If it is a kind of a relational database, right? Anyway, if you try to take any kind of a hard disk, this hard disk is going to be uh, partitioned in the form of blocks, right? You know the reason why they have partitioned to block, right? So this is block 1, block 2, block 3 and block 4. Means I have partitioned this entire hard disk into 4 blocks, right? So the reason for partitioning the into blocks means, if you have a main memory, the main memory size is very far less than the hard disk size, right? So I cannot able to place the complete hard disk into the main memory. So if somebody is requesting for certain data, I am going to request to the hard disk, please provide the requested data, right? Then it is going to send in the form of block by block, right? It will send first block 1, it will process it, then after processing again it is going to write back into the hard disk, right? Next, if it requires for block 3, then it will request for block 3, then block 3 will be sent it to the main memory, as this entire block is going to be fitted, right? So it's a kind of simple example only, right? So certain situations where the entire block may not be fit in the main memory also, right? Assume that this block is entirely fitted in the main memory, then it is going to take it and it is going to process it and it is going to send back, or it is going to persist the processed data in the database again, right? Yes. So this is what generally your main memory is going to do, right? Yes. So that is the reason they are going to divide it in the form of block by block, right? So if you try to observe the earlier class of magnetic disk, they are going to have various kind of a plotters, and each plotter contains a tracks, and tracks are again divided in the form of sectors, right? If you try to check, this is one sector of track 0, right? This is one sector of like sector 1 of track 0, if I say some general meaning of name, right? Now here I can able to place one block B1, here I can able to place one block B2, here I can able to place one block B3, and I can able to place here block B4, and so on. Like this your data is going to be stored in the hard disk. Block by block they are going to be stored, right? Now here if you try to observe, here I am saying that it's a kind of a data. Those data can be in the form of a tables. In the form of a tables, they can be stored, and sometimes this entire table may not be fitted in one particular block. So your data might be splitted into multiple blocks. Right? Yes, there is a chance. Right? Here, my entire record or my entire table is going to be fitted in the same block. So I can say that it is something like unspanned record, right? As my record is completely fitted in this particular block, I can call it as unspanned record. And here, if you try to observe, it is going to be split into two locations. One is B2, another one is B3. We can call it as spanned records. Spanned record, right? Yes. So based upon the way they have stored the data, based upon the way they have stored the files, they are classified into two types of strategies. One is spanned strategy. You can say it as spanned strategy. Another one is unspanned strategy. Unspanned strategy, right? So the meaning of spanned means here the itself is clearly defining, right? If I say this is a spanned records, in spanned strategy mechanism, the file storing will be done at multiple blocks, meaning that this spanned strategy mechanism allows us partial part of record to be stored in a block. We can call it as spanned strategy. See, if you are able to observe here, a particular record is saved in block B2, so which means that I can say it is a partial part of the record, right? And here the same record, another part of the record is going to saved in the B3, right? If you try to observe here, if I say this is something like block 1, and this is block 2. Here, why I have mentioned, why I have started partition means here, I have already saved record 1, record 2, record 3, record 4. So for the make of simply differentiation, I have mentioned some kind of vertical line here. Now record 5 I have saved. Assume that here there is 5 MB of space, but record 5 requires 10 MB of memory. 10 MB, right? Even though it requires 10 MB of memory, yes, I am going to have 5 MB of memory is available here, that I have fitted, and the remaining 5 MB of memory is going to be again partitioned, is going to be placed in another block. That is this particular example will define as spanned strategy, meaning that it allows partial part of the record, right? So partial part of the record means this is R5 is one partial part here, and this R5 is one partial part here available. This is what we call it as a spanned strategy. Right? So based on this terminologies, we can say one point, that is blocking factor. So blocking factors means the average number of records. Number of records per block I can able to store. That one I can call it as blocking factor, right? So in this particular block, I have saved 5 records, right? Not exactly 5 records, it is 4 point something, right? So on an average, I can able to save 4 records. So I can call the blocking factor of this entire disk is going to be 4. Suppose for example, if I say something like this continuously, here also something like R6, which is going to be again saved here. So partial part, right? So 4.5 I cannot say exactly in terms of points, so I can go for like 4 records, right? So the blocking factor of this entire disk is going to be 4. That is the meaning of blocking factor. Yes. Coming to unspanned strategy, we are not going to store partial part of the records, meaning that there will not be any kind of a record. So no record can be stored in more than one block. We can say that this is kind of unspanned strategy. See, for example, if I try to say like this, right? This is block 1 and this will be the block 2, right? For example, record R1, R2, R3, R4 are already fitted, and record 5 I cannot able to fit completely here. So I will just simply left this as it is. I don't want to place R5 because it is unspanned strategy. So then R5 will be placed here. Now R6, R7, R8, and suppose for example R9 also I cannot able to place completely. So then I cannot able to fit here. This is the mechanism what we are going to use in unspanned strategy. So basically, if I try to elaborate this one, so basically unspanned strategy are used for to fit fixed length records, are used for to work with fixed length records. Whereas coming to span strategy, it is work with variable length records. Variable length, right? Meaning that the length of the records can be dynamic. We don't know exactly. They are going to vary from time to time. So those kind of records I can able to use for span strategy because we don't know exactly, so that we can able to fit it multiple blocks. Right? So every strategy having its own drawbacks as well as its own advantages, right? So if I say the advantage of span strategy, the advantage is there any memory wastage? Even though I am going to have very small amount of space, I can able to store it some amount of data. So I can say that the advantage of span strategy is there is no wastage of memory. But what might be the drawback? We can say the drawback is once you try to access one particular record, you need to access many blocks, right? So that is a drawback. So number of block accesses are going to be increased. Accesses are increased in span strategy because if you would like to access the record number 5, the record number 5 is going to be available in block 1 as well as in block 2, right? So in this particular situation, I need to access 2 block accesses. Coming to unspanned strategy, those will be the advantages here, right? If I say advantages, you don't need to access more number of blocks. So you have to only access only one particular block, right? So number of block accesses are going to be decreased. Coming to the drawback, or if I say disadvantage, it's going to have wastage of memory, right? It's a kind of just according to this expense we can write, right? Because here if I'm going to have some 5 MB of memory free, I got a record of size 10 MB, I cannot able to fit, so I will go to the next location, and here this 5 MB of memory is going to be wasted. That's why I can say that is a drawback, right? So this is one way of storing your files. Right? Once they store the files, after storing the files in the internal structure of the file, they are going to be organizing the data, right? We can simply call it as organization of the records, right? Organization of the records in a file can be done again in different ways, right? So far what we did now, once we got a file, that file we have placed in the disk, that too block by block, right? Once you try to place in the block by block, in this block, how to arrange those files will be defined by organizing of data or record, right? So we can able to organize it in many ways. One way is you can able to organize all the records in some kind of order format, right? We can say that ordered file organization, right? We can able to arrange your records in the block itself in some kind of order, right? Or you may not follow some kind of order, that we can call it as unordered file organization. Right? Means once you arranged the data in a particular block, see, if I try to take, this is a kind of a hard disk, block by block. If suppose for example one file is arranged here, if this file is going to be contains records, right? This file contains certain set of records. Those records are going to be arranged in some set of order, not only in some sequence ascending, or it can be a descending, or it can be kind of sequence of alphabets, or like that, right? It can be any kind of order. Then we can call it as ordered file organization, meaning that all the records in the file, are ordered in some search key value. We can call it as ordered file organization, right? Whereas coming to unordered file organization, we don't have any kind of particular order. So they are going to be simply opposite to the ordered file organization, meaning that whatever the order that you are going to get the data, in the same order you are going to insert it, right? So here the records are in some kind of zigzag order, right? Again, once you follow this particular approach, you may have certain kind of advantages as well as you may have certain kind of drawbacks, right? So if you are trying to store your data in the form of some kind of ordered format, right? See, if I say 1, 2, 3, 4, 5 and so on, 100 records are there. If this is a kind of a file that I have saved in one particular block, this block contains data in the form of some kind of order. If I would like to search for a record number 7 or record number 47, right? Record number 47. Then how we need to search this one? As this data is in the form of some kind of sequence format, some kind of order, can I able to apply some kind of binary search algorithm? Yes, I can able to apply some kind of binary search algorithm, right? If I am able to apply binary search algorithm, then it's going to take very less time complexity. So I can say that log 100 base 2, the log n base 2 is the time complexity for binary search on an average case, right? Yes. So the advantage of this order file organization is searching a record is easy, right? Searching a particular record is going to be an efficient one. Then what might be the drawbacks? So once you try to insert some data, that will be the more expensive one. Hope you understood this one, right? Because if I got next some data like 91, right? This record I need to place in the exact order of the respective file. It's for that I need to process something, right? So that's why insertion is going to be expensive. But whereas coming to unordered file organization, what might be the advantage? Advantage is insertion is not required, is not going to be an expensive, which is an efficient one. Why it is going to be an efficient one? The order in which the file come, they will just simply append at the end of the file, right? Then what might be the drawback? So the same opposite one, right? So searching a record is not the efficient one. Because I cannot able to apply binary search. So I need to apply the searching algorithm here is linear search. Whereas coming to order file organization, the searching algorithm we are going to use as binary search algorithm, right? So this is the way your files are going to be organized, right? So this is for today's class. Thank you.